Good morning, everyone. Good to see you all here. Last Sunday, there was a Light of Truth Day talk where Joel and I presented a sketch or overview of this new worldview that we've been working on for many years now, and which one of the main goals is to show how science and mysticism can be seen as we say here every morning in that introduction, compatible ways of viewing the same underlying reality. So that was a sketch and an overview, and today I'd like to go into more detail on a few aspects of that, relating more specifically to the nature of science and math and how it fits together with this God equation that we introduced. But first of all, just a little background on why we need this new worldview. Why are we doing this? What's the point of this? The truth of the mystics is beyond all this relative truth, so why are we bothering with constructing all these imaginary distinctions in this new worldview? Well, one way of explaining this or motivating this is that our current culture is a scientific culture, and modern science has been conflated or married to the philosophy of materialism for at least a couple hundred years. And materialism assumes that the reality of the world and of everything consists of space and time and matter and energy and these physical entities that have their existence independent of and outside of consciousness. And in this view, the foundation of reality is this matter and energy within space and time. And consciousness is merely a way that this human brain functions in certain biological organisms on this particular planet within a particular galaxy in this huge cosmic space at this particular time in the age of the universe. So that's kind of the picture of materialism that has been wedded with scientific worldview. But there's some problems with materialism. I'm just going to name a few of them here briefly. First of all, it's in the last century, materialism has had some problems within science itself. Quantum mechanics in particular has had, well, it describes a world that is really incompatible with this simple materialistic idea of little particles going and bouncing around. The details of that are quite complicated, but for almost 100 years now, physicists have been trying to figure out what kind of world quantum mechanics describes. And they've failed over and over and over, and there's a dozen or so different possible interpretations of this, and they haven't settled on one. But the key thing here is that none of them are compatible with materialism. There are these features like non-locality, and some of these features have even been tested in experiments related to what's called Bell's theorem, and it gets quite technical, but the gist of it is that quantum mechanics is contradicting some of the basic ideas of materialism. So that's a problem within science itself that it has with materialism, and that's creating a tension there. But more broadly, from a more philosophical perspective, materialism has this problem that it's something that by definition is outside of and independent of consciousness. And science is purportedly this method of investigating reality that's based on empirical observation. So we're going to empirically observe things and figure out what really exists. And observation, verification with an experiment and experience is the way to test what's true. But the problem is this matter is assumed to be this thing outside of consciousness. So by definition, it's this metaphysical thing that's unverifiable in principle. We can never directly experience this matter because by definition, it's outside of consciousness. So that's another problem with materialism. Another issue is that it simply assumes that not only is there matter out there, but there are these physical laws. The matter has a kind of order to it. And materialism doesn't really explain where all that comes from. Why is this matter ordered in the way it is? Why do we have these particular elementary particles? Why is it we have these particular laws of nature? They just assume that they exist. And there's no explanation for where any of that comes from or why it is what it is and not something else. So that's another issue with materialism. Another problem that's been dogging the heels of materialism for quite a while is that materialism can't explain how it is that matter, which is the fundamental reality in that view, gives rise to subjective consciousness. It's clear that matter can give rise to brains and brain activity, but there's this subjective aspect of consciousness. There's awareness, and this has been gone by the name of the mind-body problem, and more recently it's been called the hard problem of consciousness. And that's still unresolved. No one, at least in my view, has been able to satisfactorily explain how this immediacy of our subjective experience could possibly arise from matter. Another issue with materialism is that it can't provide a basis for our spiritual values. Because matter is the basis of reality in the materialist picture, we value what's real. And if matter is what's real, our values will be based upon that. So this tends to foster an attitude that what's important, what's real, what we should value is material. And that has moral, ethical consequences. It tends to create suffering. So that's another problem with materialism. And finally, materialism is a barrier to people who want to follow a spiritual path. So it asserts that the only reality is matter, and consequence of that is that the teachings of the mystics, well, that's not compatible with this materialist view. And so the tendency is to disparage that, to look upon it unfavorably, to say, maybe even worse, it's just a bunch of hogwash. So anyone who is inclined or feels moved to follow a spiritual path, at the very least, they're going to have a tension, a conflict with reconciling that with a materialistic view that dominates culture and dominates science. So there's a conflict there, and at the very least, someone would have kind of a schizophrenic life, trying to live with these two conflicting worldviews. So with all these problems with materialism, what's the alternative? How can we avoid all those problems? Well, we could try and just ditch it and say, well, let's just get rid of this materialism in science. It has all these problems. Let's just go back to one of the traditional religious cosmologies that many human cultures had before the rise of science. Well, some people in modern times actually try and do this. You have little pockets of people who try to live a very traditional way, no electricity, no modern uh, dentistry or medicines or things like this. Um, but the fact is, the modern world as a whole is based on science, and there's going to be no turning back. There might be pockets of people who try to do this, but I think it's unrealistic that the world as a whole will be moving forward by ditching science altogether. So if there's any hope for a new worldview that honors spiritual values, it's going to have to be compatible with science. And that's one of the missions of the center, is to help make that happen in whatever small way we can. So in this new worldview, the reality, instead of being based on matter, it's based on consciousness. And our claim is that it's possible to develop this new worldview in which science and mysticism are compatible within this context of consciousness being the basis of reality. And we believe this is possible because science itself doesn't in fact rely upon materialism. It happens to have been wedded to this materialist philosophy, but it doesn't actually depend on it. And that's because the essence of science isn't materialism, but it's a specific method of investigating experience. It's about learning the kinds of order that arise in our relative world and studying them. And this investigation doesn't require that we assume that matter exists or that we assume even that laws of nature exist. It just requires that we study experience as it arises immediately. And if there happens to be order there in experience, well, then we can study that. But we don't have to assume that it exists as something objective outside of experience. So that's the basic idea here. And our task is to kind of re-envision science, view science from this different perspective. This perspective where the foundation of reality is consciousness or non-dual reality. So this is going to put science in a different context of a mystical worldview. And that will put it back in touch with this foundation of spiritual values. So we could have a beautiful worldview that is based on spiritual values and is compatible with the mystical teachings, and also provides a clear account of how science works and is compatible with science. So a scientist could live a mystical life while being a scientist. So I'd like to get into a little more detail of how this might work and provide this new view of science. So first of all, I should mention that this consciousness that reality is based upon in this mystical worldview is not a personal consciousness. It's not the functioning of the physical brain we're talking about here. This consciousness isn't an attribute of our biological organism. Instead, it's what mystics call non-dual awareness or ultimate reality. In the religious traditions, they call it by things like Buddha mind or the Tao or Brahman or God. So this consciousness is the ground of reality. It's the ground of not just our personal, limited self, but really of all reality. And what we experience as matter are imagined in consciousness. These are forms arising in consciousness. Just as a world appears to arise in a dream. If you dream of an automobile, or you dream of a bull, or you dream of anything in your dream, there's not necessarily a material object that really exists outside of the dream in order to experience that object in the dream. So we can have, dreams show us that we can have experiences of things without those things having to exist objectively outside of consciousness. So in this picture, nothing outside of consciousness has any real existence. Not matter, not space, not time. And because of that, it avoids a lot of the problems I mentioned earlier with materialism. So it avoids these problems with quantum mechanics because it's not presupposing this matter that's conflicting with these predictions of quantum mechanics. It's not supposing anything unverifiable that's outside of consciousness that we could never access. It's just dealing with consciousness and its immediate appearances in consciousness. So there's nothing extra that is being presupposed that's unverifiable. So it avoids that problem. We also don't assume that there is some pre-existing order or laws of nature that exist objectively out there somewhere. So it avoids that problem of explaining where those come from. It has no hard problem of consciousness or mind-body problem because there's no matter from which we need to explain where consciousness comes from. Consciousness is the fundamental reality, so you don't have to explain how it arises from matter. It's primary. And this worldview provides a basis for morality and spiritual values because the nature of consciousness, as all the mystics testify, is this compassionate, selfless nature that is the foundation for spiritual values. And finally, it provides, this worldview will provide a way for people to discover this truth and suffering. So just as the mystics have taught, so it's compatible with all the mystical teachings that lead to the end of suffering. So there's not going to be this barrier with materialism that we had before. So a lot of these are fairly obvious consequences. You do away with matter and you don't have a hard problem of consciousness, for example. That's pretty clear. But some of the aspects of this maybe do require a bit more explanation for how this is going to work. So, for example, what's the explanation for the order that appears in experience? Where does that come from? If it's not coming from outside of consciousness, if there's not some pre-existing order, how do we explain that the sun rises every day, over and over, that there do seem to be these regularities that physicists identify and call the laws of physics? How do we understand that in terms of this picture? And the other question is, why does science in particular seem to work so well at predicting things so precisely and reliably? That's something that a lot of materialists would want to have explained before they switch over to some crazy mystical view of reality. They want to say, well, how could this possibly explain how there can be laws of physics if there aren't these objective laws that are out there that explains how we all agree on things? How can you explain that in terms of consciousness? So I'm going to take a closer look at these two, and we'll see if anything that I say is satisfactory here. But first, in order to do all of this, we need to talk about language, because any worldview, one of the several things that compose or constitute a worldview is a language, a common language to describe the world and what it's made of. And if we're going to have a single worldview, with science and mysticism being compatible, we need some kind of common language to express this in. And the language of science is mathematics. Mathematics is essential to science. It's essential to our empirical measurements, which depend on mathematical quantities, numbers. So we make measurements, and that's all in terms of these mathematical quantities. And our theories in science are mathematical equations that we plug these numbers into and solve and predict new numbers to go out and measure. So this mathematical language and mathematical quantities in particular are very important in science. And what's key about this language is that this language of mathematics is that it's very clear, unambiguous, and precise. And the paradigm of mathematical language is quantitative numbers. So that's kind of the paradigmatic example of one of these precise, clear-cut distinctions, is just defining the numbers 1, 2, 3, 4. These are clear-cut and precise. There's no confusing 1 with 2, 2 with 3, no ambiguity there. So in contrast to qualitative distinctions like, oh, we have a few of something or we have a lot, these quantitative numbers are very clear-cut and precise, which is contrasted with the more fluid and ambiguous distinctions in natural language. So in our natural language, we talk about things being near and far, short and long, big and small. If we want to be more precise and less ambiguous, we start to quantify those with numbers like, well, this isn't just near, it's a certain number of inches or feet. This isn't just vaguely far away, it's a particular distance that we measure using, say, miles. You might have noticed in your own life that people can disagree, for example, about how warm the house is. It's one person thinks it's too hot, another person thinks it's too cold. Well, these hot and cold distinctions are kind of vague, and they're somewhat subjective as well. So what science does is it says, okay, well, let's get this device, we'll call it a thermometer, we'll calibrate it against other thermometers, and it'll read a scale, and we can both agree that it's 65. Now, 65 may be too cold to you, but it's still going to be 65, or it could be 75, and maybe 75, well, that's too hot for one person and it's just right for another. And this helps us distinguish what is the objective temperature in the room and what is our preference for our comfort of a particular temperature. And that's done by quantifying these properties in our experience. Now, in contrast to science with its traditional use of mathematics, in mysticism, it doesn't traditionally use mathematics. At least it doesn't seem so apparent in most of the mystical literature. Words in mysticism are often used symbolically or metaphorically. We also have expressions with art and music. And these are all qualitative distinctions and expressions that don't have this precision that mathematics does. But there are also, we do find kind of an exception to this. We do find in some traditions reason and logic using precise distinctions. For example, in Hinduism, you have philosophers like Shankara. He used very rigorous logical arguments in the context of mysticism. You have in the Buddhist tradition Nagarjuna and other philosophers who use logic in a very precise way to the end of revealing mystical truths. So you do have reason and logic, which are clear distinctions used there. And in fact, some mystics have actually said that mathematics can be a language to be used to express mystical truth. So, for example, Nicholas of Cusa, Christian cardinal, wrote a book called Deducta Ignorantia. And he wrote this in there, which is quite interesting. He says, since there's no other approach to a knowledge of things divine than that of symbols, we cannot do better than use mathematical signs on account of their indestructible certitude. And our beloved Franklin Merrill Wolfe has also advocated for the use of mathematics as a way to express mystical truth. And here's what he writes. The immediate content of the higher consciousness cannot be cross-translated, by which he means take this transcendent, ineffable reality and express it in terms of relative distinctions in language. Which is basically what Nicholas of Cusa said, that since there's no other approach than that of symbols. So continuing, he says, the immediate content of the higher consciousness cannot be cross-translated, but certain formal properties can be through the use of systematic symbols. In fact, if the consciousness equivalence of the entities and operations of pure mathematics were realized, we would find that in that great science and art, cross-translation in a lofty sense already exists. So he's saying here that this language of mathematics can be a powerful way in which to express some of these mystical truths. So in our worldview, we're claiming that math can be this bridge, this common language that helps show how science can be viewed within mysticism. So how can a mystical truth be expressed in this precise language of math? Well, our approach is to trace language, and in particular the language of math and mysticism, back to its very roots in this power of imagination to make distinctions. To identify any object is to distinguish it from what it's not. So if I want to say gong, I have to distinguish this from what it's not. And that applies to abstract words and applies to concrete phenomena arising in awareness. Any object that arises, not only is it going to be distinguished from what it's not, but it's going to be distinguished from the awareness in which it arises. Insofar as it's cognized as a phenomena arising, it's distinguished from awareness. But the mystics say that although the phenomena and distinctions appear in this relative sense, in an absolute sense, they're identical with the consciousness in which they arise. In other words, the distinctions upon which the objects are made are imaginary and not real. The distinctions arise, but they don't truly divide reality. Reality remains one in this imagined diversity. So this activity of imagining distinctions is real, it happens, but it doesn't make real distinctions. There's no, technically these distinctions in reality should not be or cannot be reified or made real. So in mystical traditions, they talk about this using metaphors like Shiva and the dance of Shiva are the same. There's no separating this reality from its manifestation. An ocean and the waves are the same. There's no separating the ocean itself from its manifestations. So in your own experience, you can imagine a space and imagining a distinction, distinguishing the right side of the room from the left side of the room. You can imagine that distinction in that space, but that doesn't really divide the room in half. The space remains an undivided whole, despite imagining that distinction in it. So this act of imagining doesn't create a real division. There's not a real duality of imagining distinction and not imagining distinction, manifest and unmanifest. So all words and distinctions are based on this imagination of distinction, but these distinctions don't create real separations or divisions. So this is why ultimately we can't say anything about the ultimate reality, because to say anything definite about it, we're kind of assuming that the distinctions are real. Oh, here's a real distinction. I've just made a word and I'm going to say that that describes reality. Well, that's reifying that as a true description of reality, but ultimately these distinctions are imaginary. So ultimately this reality is ineffable. And if we start grasping onto these distinctions and concepts, this would be to reify them and imagine that somehow they really divide reality somehow. Okay, well, that's all fine and good. But if we're going to talk about experience and worldviews and things like this, we are by definition presupposing that there are these imagined distinctions, that appearances arise. So there's this activity of imagination, and forms arise in consciousness through this power of imagination. So duality arises within this context of non-duality. And if we're going to talk at all, we could say that reality is both one and many, or both non-dual and dual. The dual aspect being the manifestation of forms arising, appearances, and the non-dual aspect being the identity of these two. The identity of the manifest and unmanifest, the subject and object. So if we attempt to express this play of manifestation in a mathematical language, here's one way we could do it. There's nothing that's absolutely true about this. These are just distinctions we're playing with, right? So we can let this omega symbol, we can say that this is reality. This symbolizes reality. Of course, we already have a problem because reality is beyond subject and object. And well, here's an object. It's a form arising in consciousness. But we're saying that, oh, well, this form actually points to the formless. And so we're already kind of caught in a bit of a paradox here. But this is true of any symbol. And if we're going to express things in symbols, then this is the game that we're playing. We have to remember that these are just symbols. So we say, okay, well, here's the symbol. We're going to say it represents reality. But then we want to say that this symbol is not an object. It's actually identical with this non-dual reality, that this reality is beyond subject and object. So to start to talk about reality being beyond this distinction, we need to symbolize distinction. So we create the second symbol that's going to represent the act of making a distinction. And this allows us to then distinguish reality from reality with a distinction in it. And so now we can start talking about two different things in reality. We can start talking about form and emptiness, subject and object, manifest and unmanifest. But we don't want to forget that these are identical. So how do we say that in mathematics? Well, we set them equal to each other. We say form is emptiness, manifest is unmanifest, subject is object. And so this is what we've called the God equation. It's trying to express in symbols this ultimate reality that ultimately can't be expressed in symbols. But this is taking a shot at it, right? And it's using the language of mathematics, and in particular, the language of distinctions. So we also have to, we don't want to cling to this either, right? This is the absolute truth that form is emptiness, but we don't want to get stuck into saying that there's no form arising at all. So we can complement this with saying, well, there can arise a distinction between form and emptiness. And in that case, they're not equal. So these are like two different perspectives on the nature of reality, the ultimate perspective and the relative perspective. And of course, we can try and say, well, now these two express reality more completely, but of course, that's not something we can cling to definitely either. So, but it's like the more you try to precisely describe reality, the more elaborate the description becomes, because it always needs to correct itself. It's always going to be incomplete. So we no matter what we say, there's a complement to that we've left out. And this is what gives rise to the diversity of expression. So here we've used the language of mathematics to express at least part of the fundamental teachings of the mystics. And of course, math is also the language of science. That's obvious in terms of just the fact that numbers are used. But I wanted to say a little bit more about that, because what we've done in the case of mysticism is we reduced language to this idea of making distinctions. And we'd like to do that in math as well, so that both the language of mathematics and the language of mysticism are both united in this core concept of making a distinction. So how can we understand quantitative numbers that are used in science in terms of making distinctions? Well, there's a kind of unconventional way of doing this, which I think is very clear, but it's not as common. So instead of describing that, which I've done before, today I'm just going to describe it in terms of set theory, which is a very standard way that mathematicians use to describe lots of structures in mathematics. They use this language of set theory. And a set is just the idea of containing something, making a distinction to distinguish what's inside the set from what's outside the set. So it's just the same idea with our experience. We distinguish what's inside this boundary around the bowl from what's outside, what it is from what it's not. So the idea of the set is just this. It's making a distinction between what's inside, what's contained in it, and what's outside. And what's interesting about mathematics is it doesn't start with any raw material other than just making a set. So the very first set that's made in set theory is called the empty set. And it's the set that contains nothing. You start with nothing, and so what do? Well, you make a set that has nothing in it. Well, now you have something. You have a set. Inside the set is nothing, but the set is something. So you've distinguished something from nothing with this first distinction. And now you have this first set. And how many things does it contain? Well, it contains no things, so we call it zero. Now we make another set, and this set, we say, well, what can be in that set? Well, that previous set, the empty set, we can put that in here and make another set out of that. And how many things does it contain? Well, it contains this one thing that we created before, the empty set. And so we call that the number one. And if you go on like this, here's a little diagram. It gets more complicated, but the basic idea is this is the way that mathematicians write the empty set. The curly braces mean what's inside the curly braces is what's inside the set, what it contains, and what's outside, of course, it doesn't contain. And the first set, well, there's nothing inside those braces. So it's the set that contains nothing. That's the empty set. That's zero. We call that zero. And then the next set, we say, okay, well, let's make this what contains this next set. So this next set, here are the braces around that. It contains this set here. So it contains this one thing, so we call it one. Well, now notice we have two things. And so we can make another set that contains these two things. It contains this thing and it contains this other thing. And so it contains these two things. We put those in brackets to contain them both together, and we call that 2. And then we do that with 3, and it contains these 3 things. See, we have 3 things here. And so we have a set that contains those 3 things. And as you can see, this, you start to get a lot of curly braces very quickly. But the gist of it here, which is all you really need to worry about, is that from just this idea of making a distinction, you can build up these numbers, these quantities, these clear mathematical quantities, and you can manipulate these sets that in ways that correspond to adding numbers together. You can add 1 plus 1 and get 2. You can add 5 and 7, get 12, and things like that. You can define that in terms of these distinctions, these sets, and how they can be manipulated. So from just this idea of making a distinction, you get numbers, you get arithmetic, and you get all of these mathematical properties. We normally write them using these Arabic numerals, but fundamentally you can think of those as being just created from distinctions. So that's the key idea that I wanted to get across here with that. So with all of mathematics expressed in terms of this idea of making a distinction, and these mystical teachings expressed in terms of this idea of making a distinction, we now have this common language to express both mathematical quantities that we use in science for measurement and for equations traced back to distinctions, and also these truths of mysticism, like the ultimate truth and the relative truth. We can express that in terms of these distinctions as well. So now we have this common language for expressing both these truths, which is really the core foundation of this new worldview. And we can use this to help understand how, for example, there can be order in experience. So how is it that from this perspective of distinctions in consciousness, how is it that certain kinds of orderly regularities are in our experience? How can we understand that? What's the explanation of that from this perspective? Well, we've already described this God equation and how it expresses the truth of this first distinction between form and emptiness. And we can see how this first distinction is the seed for all objects arising in consciousness. We've already touched on that, actually, of how any object that arises in consciousness is distinct from the subject. Any phenomena is distinct from the awareness within which it arises. So that first distinction between subject and object is the seed of the orderliness there. You could say that any manifestation has this subject-object structure to it, and that's a kind of fundamental order that's going to be common to any experience whatsoever. So right there in that seed of the first distinction is the seed of order as well. It's also the seed of time and space. So to give an example with a sound, if I ring this gong, you're cognizing the sound that's now present, this object, and that's identified as an object because it wasn't there before. There's something new. And then the mind cognizes that as an object. Oh, something arose, this new object. And that's only possible if it hadn't been there before. So there's implicitly, in the arising of any object, this distinction between its past absence and its current presence. So built into the arising of any object is this distinction between past and present. And similarly with space, if you see this suddenly arising in your field of sight, this implies a distinction between where this is in that field of sight and where it isn't. So it's present here and it's absent over here. So implicit in something arising in some definite way is a distinction between its presence here and its absence elsewhere. So this is the basic seed of the idea of space. Space, something here as opposed to there, right? This separation. That's just the seed of space, which is really built into that first distinction when something arises. So this first distinction is where time begins, it's where space begins, and these are also structures of experience. Our experience is structured in terms of sequences of things in time and distributions of things in space. And that kind of structure and order is built into this first distinction, and it provides a kind of context within which other more complex forms can arise. So if you, for example, are watching a still pond and a dark cloud slowly comes in overhead, and then you see plop, a raindrop drop in that pond, and then plop, another raindrop in another place, and then plop, another raindrop. There's that experience is structured by space and time. The raindrops are in a temporal sequence. First, there's that first drop, and then there's that second drop, and then the third. And also, the first two drops might be very close together in the pond, and the other one farther apart. And so there's a kind of spatial order to that as well. And that kind of temporal and spatial structure is common to experience. It's a kind of order and experience. And so we can understand how experience can be ordered by just looking at the way that these distinctions of time and space arise and how they operate in our direct experience. We don't have to assume that there's some space that objectively exists or some time that objectively exists, and we're somehow here flowing through it, located here within it. Time and space are these structures of experience that arise with these distinctions in experience. There's nothing outside of experience that we need to explain that order. So we're not talking about physical space and time that objectively exists here. We're talking about experiential space and time. So building on this basic distinction between like past and present, this is just a very simplest of all distinctions in time. You can imagine building up other kinds of distinctions. So the plop in the water, the spacing between them temporally, they might be coming in fast or slow. When the rain starts falling hard, you'll have lots of drops of water. If it slows down, you'll just have plop and then plop and then plop. And so we might create another distinction in our experience between heavy rain and light rain, or short duration between the raindrops and a long duration between the raindrops. So these are other kinds of secondary distinctions that we might build upon that first distinction between past and present. And those are still qualitative distinctions, though. Other distinctions we have in our experience are like our heartbeat. We might notice it's fast sometimes and slow other times. And all humans will make these kinds of distinctions because we all have heartbeats. Not all the time, of course. In dreamless sleep, you don't have an experience of a heartbeat. Maybe in dreams, you don't necessarily have experience of a heartbeat. But when we are awake and we're feeling our heart, we will feel it either pounding hard or pounding soft or pounding quickly or slowly. And so as humans, we'll tend to make these similar distinctions. And so we can then talk about these distinctions with each other. And it seems as though there's this, we might say there's a shared objective order here, but actually it's just we're drawing these distinctions in the same way. And these aren't assumed to be objectively existing. They could arise in another way. They could arise not at all. If we're a jellyfish or a starfish, we don't even have a heart. There's nothing to beat. There's no distinctions about that being made. So consciousness is, in this picture, it's free to imagine these distinctions arising in lots of different ways, and in particular, they can arise in a human way. But consciousness is also free to imagine distinctions arising in non-human ways, like other creatures might experience. So the intersubjective agreement between humans about certain kinds of order and experience, about space and time and certain patterns, is just one kind of possibility. And there might be many ways consciousness can manifest with other kinds of order. So we're not presupposing or positing some fixed objective order in reality, but when consciousness creates distinctions in the same way, which we might call a human way, then those humans will all have certain things in common in their experience because the distinctions are created in this similar way among all humans. So we can understand how there's this intersubjective agreement among humans based on the fact that distinctions are arising in a similar way for all humans. So what about objective things, so-called objective things like bowls? How do we explain the order of things kind of outside of our body? Well, when this appears in the visual field, there's kind of a sequence of visual phenomena in time. So at first there's no bowl in the visual field, and then it arises, and then as the moments go through time, we notice in space the shape is changing. There's a difference maybe in color and in shape. And so there are all these differences in the appearance, but there's also a kind of similarity. There are correlations between these. For example, these are there's this common roundness. There's it's all one contiguous space. There are lots of different colors here, but it tends to be certain shades of, I guess you could say brown, maybe brown and yellow. And what we can do is we can make a distinction that kind of collects all of those together and say, well, these seem correlated with each other in a certain pattern. There's a pattern to these. Just like all the raindrops are different, but we still call them all raindrops because there's a similarity to them. So all these different visual phenomena are different, but there's a similarity to them, and we correlate them to each other. And we say, well, this I have a model of what's giving rise to these appearances, and it's this idea of a 3D bowl. Our visual appearance here is two-dimensional, but we have this idea that there's a three-dimensional object, and you can put things inside the bowl and so on, and it can hold liquid. And those are all kind of three-dimensional properties. But that's an idea, that we have this idea of a three-dimensional thing. We don't experience a three-dimensional world. We experience in our perception 2 dimensions, and then we imagine these three-dimensional objects that give rise to it. So sometimes when we construct these kind of models of our experience, we find that lo and behold, some other people agree with us. Oh, well, you see a bowl too? Yeah, and it can hold things. And then we have this shared language about this, and we're making the similar distinctions. And there's this intersubjective agreement about this particular phenomena. And if that happens, we can then act as if it has a kind of objective reality to it, just because we're both agreeing about it. So these objects with intersubjective agreement are then part of a shared world model. So you then have intersubjective agreement about these models that are constructed that correlate to our experiences. But not all of our experiences are going to behave this way. Not all of them will have this property of being able to be correlated with other objects in a way that other people will agree about it. So, for example, if I'm hallucinating, if I have certain thoughts or emotions or things or dreams, those I can have ideas about what those are and what they mean, but they won't necessarily be accessible to other people, or other people won't agree with me about those. So those are phenomena that are arising that we would call subjective instead of objective. Or maybe better terminology would be private versus public. So if there's intersubjective agreement about certain phenomena, we call them public objects. And if there's not, then we call them private. So the so-called objective world, this shared public construction, is really just shared features of these certain parts of our experience that are amenable to intersubjective agreement. And that's not all of our experience. That's just a certain subset of our experience where there is certain intersubjective agreement. So from this perspective, consciousness is free to imagine all kinds of distinctions in all kinds of different ways. And sometimes consciousness imagines distinctions in such a way that there will be intersubjective agreement about them. Other times it will imagine distinctions in a way that there isn't intersubjective agreement about them. And when there is, we say, oh, well, those distinctions correspond to the objective world. And when there isn't, we say, well, that's my private subjective experience. And that's a distinction we make as well in experience between the public intersubjective world and the private world. So consciousness freely imagines all of these distinctions, and some of them have these kinds of intersubjective order to them, and some of them don't. And so we explain this intersubjective order by the fact that simply consciousness is free to do both, and sometimes it does one. And that's where it comes from. So this order is ultimately based on these imaginary distinctions, and we shouldn't reify them. this view of order in experience is a play of distinction within consciousness. And according to the mystics, the nature of distinction is that it's not ultimately real, but it's imaginary. So there's just consciousness and this power of imagination, and nothing objective outside of consciousness is needed to explain the fact that sometimes distinctions arise in such a way that there's order in experience. So that's I guess, a sketch of how I describe how there is this order in experience in this model. And then the second question to address is, why is it that science is able to so precisely predict things? The traditional worldviews were not able to do things like this. So what makes science work so well? How can it predict these things with such precision? Well, briefly, there are two basic reasons or explanations for how it can do this. One is that it uses standardized, refined instruments and methods of observation, and this is what ensures repeatability. And the other is that it uses this special language of mathematics, this quantitative language in both its theory and observation. And this makes these clear and precise distinctions, such as these quantitative numbers. And this use of standardized methods of observation and this precise language, quantitative language of mathematics, these work hand in hand to provide this rigorous method of recreating these precise, reproducible experiences. So let me give some examples of how this works, some simple examples that I think will illustrate these ideas. Let's take, for example, counting apples. Let's say you have a bunch of apples in front of you. You're gonna make applesauce, and here's a bunch of apples in front of you. Well, how many are there? Is there enough to, for your recipe? Or are you going to be able to give applesauce to all the people in your family or not? Well, instead of just looking at this vaguely and sort of eyeballing it, saying, oh, there's a few, oh, there's not enough, there's too many, what we can do is this thing called counting. And it's a way of determining assigning an exact quantitative number to that collection of apples. It's very precise and unambiguous. And if we do this, then we can answer questions like, well, do I have enough apples for this recipe? How many exactly do I need? Or if I picked them and then brought them into the house, I can count them before, count them after, and I can answer questions like, well, did one go missing? Do I still have them all? If I'm just eyeballing it, I probably wouldn't be able to tell. But if I count them, then I can say, oh yes, I got a different answer both times. So one of them must have gone missing. Did I drop it somewhere? Let me go look for it. So without precise counting, we can't do these kinds of things. We can't be as precise in determining whether our recipe is going to have enough or not. So then I can do more complicated things, like I can count the apples, count the people, I can count the number of apples per person that are needed to make a bowl of applesauce for each person. I can multiply those to get the total apples needed for the batch. I can, do all of these things with counting, with these quantitative numbers that I couldn't do if I'm just eyeballing things and just estimating, oh, I have a few, I have a little more. It works much better than just guesswork or a vague sense of how much there is of something. So this is really the basic principle upon which science operates. It's just a refining of this common thing we do in everyday life. And the other key feature is the use of standard observational methods. If you and I are making measurements in different way, the results won't be the same. They won't be reliable and repeatable. So in the case of apples, well, you could say, well, what counts as an apple? If you're going to count the apples and I'm going to count as an apple, we both have to know what counts as an apple and what doesn't count as an apple. Otherwise, we won't count them the same way. So we need what you might call shared standards of distinguishing apples from non-apples. We're both going through the apples. Whoops, that's not an apple, that's a pear. Well, we need to be able to know the difference between apples and pears. And if we don't, if that distinction is vague, then the results of the counting won't agree. So to ensure the agreement, we agree on this clear distinction between what counts as an apple and what doesn't. So again, it's making these clear distinctions and then agreeing upon them so that when we both engage in this act of counting, we're likely to get the same result. And we may have to agree on other distinctions as well, like, well, how big exactly does it need to be before I count it? If there's just a tiny little apple that hasn't grown yet, do I count that? So we just need to agree on these kinds of distinctions before we count so that we will ensure that we get the same result. So notice what we're doing here. We're by design agreeing on these things so that we get the same result. So it's not that this result exists objectively independent of anything. It's that we are constraining how we observe things, how we count things, in order to ensure that we get the same result. So this is how science works. It's more refined than just deciding what is and isn't an apple. In science, we need to agree on our units of measurement. We need to agree, we need to calibrate them. We need to make sure we're performing the measurement in the same way. We need to make sure that the system that we're measuring is the same, that we're both measuring the same kind of object, that we prepared our laboratory in the same way. And if we don't agree on these standards, and if we don't follow them, then the results of both of our observations may be different. And so the key to making sure that science has this consistent ability to predict things is that we are by design standardizing how we observe things. So what's observed and how we observe it are co-arising together, so that if there's ambiguity in how we observe things, then there's going to be ambiguity in what we observe. So by making precise how we observe things, we make precise what we observe. And this is what makes science so powerful at being able to predict things with precision and reliability. So in summary, the big picture here is that when consciousness manifests forms through the power of imagination to distinguish, various kinds of order can arise. When distinctions arise in certain ways, it results in common structures of experience, like a human experience. When distinctions arise in other ways, experience has other structures, such as other creatures might experience. Parts of our experience that have intersubjective features in common form what we call the public or objective world. And the other parts that aren't intersubjective, we call our private or subjective part of our experience. And consciousness is free to manifest in all these different ways. There's no limit to how it can possibly manifest. And we can investigate this intersubjective part of experience by standardizing the ways we observe and measure. And this can be made precise by using this quantitative language of mathematics to use these precise distinctions so that we can make precise predictions. And that is the explanation in this context, in this worldview, of how it is that science works, how it is that it is able to do what it does without assuming that there's this objective world out there. This is all an explanation in terms of what is immediately verifiable within consciousness. So, like all experience, science uses distinctions. It's very useful in a relative context, but of course, these distinctions are imaginary, just like all others. And suffering arises from reification of these distinctions. If we think that these distinctions science is making are describing some real objective world, well, then we get into trouble. Just like if we're playing a game, let's say you're playing tennis with your friend. To play the game, you start out by making distinctions. You agree on where the boundaries of the court are. You agree on the height of the net. You agree on how to keep score, and so on and so forth. And without those distinctions, there is no game. You can't play. You can't enjoy playing a game with your friend without making those distinctions and agreeing on them. And really, to enjoy the game, you have to take those distinctions seriously. You can't just say, "Oh, these are all just imaginary distinctions. It doesn't matter if the ball was out." You're going to end up arguing about every point, and it won't be a fun game unless you take those distinctions you've drawn seriously. That doesn't mean you believe they're ultimately real. You can still know they're imaginary, but you have to take them seriously. And similarly, your friend becomes your opponent. You're trying your best to win the point, not just to let your friend have the point because they're your friend. To enjoy the game, you have to immerse yourself into it, take those distinctions seriously, and yet, ultimately, they're imaginary. So if you lose the game, it's great. You enjoyed playing the game with your friend. You can congratulate your friend on all their wonderful shots that they made, and it was so exciting because you both threw yourselves into it. And took those distinctions seriously without forgetting that they're ultimately imaginary. So it is with life, and science is no exception. So the lesson here is it's possible to do science without reification of its distinctions and without materialism in particular. And it's possible to see science as one way that consciousness manifests through distinctions within non-dual reality. And this way of viewing science can help scientists who are so inclined to be liberated from reifying distinctions at any and all levels of their activity, and allows them also, if they want, to trace back all the distinctions they're making in their experiments, in their mathematics and everything. You can trace all those distinctions that they're making back to that first distinction. So it potentially could even be, if they're reflecting on all those distinctions they're making in that activity, it could be a way of tracing yourself back to the very first distinction. So this worldview offers a view of science that's compatible with the truths of mysticism. Scientists don't need to be deluded and reified distinctions of self, world, space, time, matter in order to engage in science. And a scientist can be an enlightened scientist, making those distinctions, taking them seriously, but realizing with wisdom and compassion that ultimately they're imaginary. and this this activity can be understood as grounded in this compassionate nature of consciousness itself. So that's the picture that we're offering, the new worldview. And finally, it must be said that this worldview, like any other, is just another worldview. It's a relative manifestation. It's not some ultimately privileged worldview or anything like that. But we hope that this offering will nevertheless be relevant to our current world situation and hopefully beneficial to certain problems in the human condition at this particular time and place.